about. Ooh, I want to choose some yellow today. All right, so there's 10 prefixes when talking about covalent naming. All right, so covalent, oh, actually, I'm going to write in the pen. There we go. So covalent naming has 10 prefixes. All right, 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta. Hopefully that's kind of, you guys remember that. 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Hopefully those 10 prefixes are kind of still in our brains a little bit, okay? And when we named ionic compounds, what we did was we had a prefix for the element 1. However, we never used mono. Mono's the exception. All right, we never used mono. Okay, I'm going to zoom in a little bit more. And then we had element 1. And then we had the prefix for element 2, so prefix. And then we had element 2. However, this ended in IDE. So hopefully that kind of looks like a familiar. So one example might be, what is N2O5? What is N2O5? Well, I got to start with my first prefix. Well, the prefix for 2 is di. The element, well, N is nitrogen. The prefix for the second element, 5. 5 is penta. And element 2 ending in -ide. Well, oxygen ending in -ide would be ox-ide. Okay, so hopefully that's a little bit of a review. And when we talked about ionic naming, there's no prefixes, right? No prefixes. It made our job so much easier. All right, so all we had to do was element 1, element 2. However, element 2 ended in -ide. All right. However, the one thing that we did discuss with ionic is the crisscross method. Okay? And the crisscross method is, let's say I have sodium nitride. Sodium nitride, and I got to write the symbols down for sodium nitride. Well, sodium is Na, and nitride is nitrogen, which is N. Now, if you guys have your periodic tables at home, this would help. But do you guys remember what number is on top of the first column? On top of the first column, there's a number 1. Okay? And on top of nitrogen's column, there should be a 3. There should be a 3. And this is where the crisscross comes into play. So when you crisscross, what it's going to look like is you're going to have 3 NAs, and you're going to crisscross this over, and you're going to have 1 N. And that's what the crisscross method looks like. Do you guys kind of remember that pretty well? Is there any questions on the compounds part of it? Not too bad. All right. Now, we talked about compounds. So these were all compounds, okay? Now, what we're actually going to talk about is we're going to talk about matter, okay? Matter is anything that has mass or space, takes up space. Anything that has mass and takes up space, okay? So that's like practically everything, right? What isn't matter? Can you guys think of an example that isn't matter? What is something that doesn't have a mass and doesn't take up any space? Anybody got a guess? Oxygen?
Mr. Bowers.
Oxygen has a mass. Yeah, I had a question.
Mr. Bowers.
Yeah.
One of my email is not working correctly. It's choosing the wrong email, so it's got the wrong name on it, by the way.
That's okay.
Just letting you know.
Yeah. You're good. Let's see. I had some messages. Let's see. Light. Ooh, light is a great example. Heat is a great example. Gravity. Gravity is another example. All of those are great examples of anything that doesn't have mass, right? So matter can actually be broken down into two categories, okay? So we have matter, and we're going to break it down into one thing called pure substances and another thing called mixtures, all right? And I know you guys know mixtures. And from pure substances, we already learned these two. We already learned elements. We know what elements are. We know the periodic table. And we just learned about compounds. So we already learned the two pure substances. So what we're actually going to do next is we're going to learn the two mixtures. And they're they're actually opposites. But one is called homogeneous, and the other one is called heterogeneous. All right? These are the two types of mixtures that we're going to talk about. Okay? And homogeneous actually it's when you mix something. It's kind of like when you mix something like, oh man, what's a good example? Does anybody like coffee? Does anybody like coffee? Yeah. So what you have is you have the coffee beans or the coffee powder. And what you guys do is you stir it in with the water and you make coffee, right? It looks uniform throughout. It's not water. You're not tasting the beans, right? It's kind of uniform, all right? And that's what this is, all right? Homogeneous is uniformly mixed. It's uniformly mixed, okay? Examples of that could be coffee, maybe chocolate milk. Maybe if you add Mio, has anybody ever had like Mio or lemonade? It looks uniform throughout the entire mixture. Milk, there's so many ingredients to milk, and that's homogeneous. Where heterogeneous is not uniformly mixed. So you can see each ingredient, essentially. You can see each ingredient. So a heterogeneous example would be something like, trail mix. All right, in a trail mix, you can see the cashews, you can see the raisins, you can see the peanuts, the M&Ms. All of those aren't mixed, right? In a, in a chicken noodle soup. I like chicken noodle soup. What you got is, you got the chicken, you got the noodles, you got the carrots, you got some people add broccoli, you got the broth. There's so many different things that you can see. And that's what a heterogeneous mixture is. Does that kind of make sense? All right. That's the biggest thing I wanted to focus on today is just the two types of mixtures. All right. The only other thing I want to go over that's on the study guide is temperature change or phase changes. And I know you guys already know phase changes, but I'll go over that real quick and then we'll get into the activity for the day. Justin, you're looking awfully comfy right now. I'm just kidding, giving you a hard time. All right, phase changes, real quick. So we have solids. We have liquids. And we have gases. Okay. Now, solid to a liquid is melting. Liquid to a solid is freezing. Right? Liquid to a gas is evaporation. Gas to a liquid is condensation. Gas to a solid is deposition. And solid to a gas is sublimation. Okay, so those are the 6 phase changes. There's actually plasma out here, and we might actually get to that when we talk about nuclear chemistry, but we're not going to get that. We're not going to cover that in the mixture and compounds chapter. All right. So those are the 6 phase changes. So what I want you guys to do for now is on Google Classroom, what I did was I posted a little, let me see what it's called. It's officially called the study guide, okay? I posted a study guide that takes you through everything we learned in this chapter. Now, no, we're not going to have a test tomorrow, but we are going to play a review game tomorrow, okay? And hopefully you are able to do most of the things on that chapter or on the study guide. So this class gets done at, I have it written down somewhere, 9:45. So about 9:25, let's come back together and I'm going to go over the answers to the study guide. Does that sound good? So at 9:25, I'm going to write myself a note. 9:25. So that gives you about 30 minutes to work on the study guide, and then the last 20 minutes I'll go over the answers. Sound good? Now, you guys don't have to stay on the Google Meet this entire time. That's up to you. But I will stay on the Google Meet if you guys have any questions throughout. If not, I will see you guys at 9:25.